Now that our backend server is live, it's time to focus our attention on the front end. Our goal is to provide a search input that when typed into will automatically filter the results from the server. As an added bonus, we will cache the last search result in the browser, so if the user refreshes the page, their last search results will still be present. The first problem we need to solve is how do we get the user's search query? The first step is to add a form input to the UI, so let's go ahead and do that in the JSX. Now we want to fetch data from the server anytime the user types into this form, and we can do that by listening to the onChange event. There are a variety of different events you can listen to when working with forms, like key up and key down, but onChange will fire whenever the value to the form changes. We can test that out right now by adding a function to handle it that will console log the event target value, which is what the user actually typed into the form. Go ahead and test it out in the browser, and you should see a different value logged anytime you type into the form. That's how we get data from the user. Now we need to take that data and send it to our server so it can return the data that the user is actually looking for. For that, we'll need to add some state to this component with the useState hook. We'll start with an empty array to represent the animals that will eventually be returned from the server. We don't have that data yet, but let's pretend like we do and go to the UI, and we'll loop over the animals using map to show a list item for each individual result. We'll first show the animal type, followed by its name and age. That'll give us a new list item for every element in the array, and then we'll also want to add a key to it as well, so React can handle updates to the data properly. As one added touch in the UI, you might check to see if the array length equals 0, and if it does, show a message like no animals found. Now, whenever I work with a loop in JSX, I ask myself if this UI should be extracted to its own component. If it's really small, it might not be necessary, but let's go ahead and do it in this case anyway. We'll create a new function called animal that takes the type, name, and age as props, then returns the list item. We can now use this component to replace the original UI, which makes our code a little more readable and maintainable. When passing the props, we can also use spread props here to make it a little more concise, although that part is entirely optional, and not everybody likes to use that syntax. And now the question becomes, how do we fetch data from our server? To handle that, let's go ahead and create a new function called search. We'll make it an async function that takes a query as its argument. The query is the event target value that's typed into the form, so let's go ahead and replace our console log with the search function. From there, we can make a request to the server with the browser fetch API by pointing it to the URL of localhost 8080. In addition, we'll add a question mark after it and provide it with a URL search parameter that has a name of Q. URL search params class that you're seeing here is built into the browser, and we'll just format it properly into Q equals whatever the user types into the form. Next, we'll convert the response into JSON and then set that data as the state on the component. When that data changes, React will automatically re-render the list of items to show the latest results in the UI. Now let's go ahead and test it out in the browser. Type into the form and you should instantly get results back from the server. That's pretty cool, but let's go ahead and make one other improvement to this app. Notice that when you refresh the page, the results are gone. We can fix that by caching the last results in the browser. In our React code, let's bring in the useEffect hook and add an empty array as the dependency. This tells useEffect to run this function only once when the component is first mounted. Now inside the function body, I'm going to use the local storage API that is built into the browser to get an item called last query. In local storage, you can store arbitrary key value pairs. Last query is simply the last value that the user typed into the form. We can then automatically run our search function, which will update the query as soon as the component loads before the user types anything into it. The only other missing piece is that we need to update the last query in storage whenever the user types into the form. Let's modify our search function to call local storage set item with a key of last query and the value as whatever the user types into the form. Now this time, after using the app and refreshing the browser window, we still have results that are relevant to what we were searching for. In other words, we used a side effect when the component was first mounted to automatically update the state on the component. As the component grows more complex, one thing we could do to make it more efficient is extract the logic into a custom hook. A custom hook is just a function that we might call something like useAnimalSearch. All we have to do is grab our logic here and paste it into the body of that function. Then as the return value, return the search function as well as the animal state. And now we can use that custom hook in the app component to keep our code much cleaner. And we could also use that hook in other places if there were additional components that wanted to run the animal search. And that brings us to the end of the first project. Understanding how to work with useState, useEffect, and build your own custom hooks will take you very far in React. In addition, knowing how to throw together a node server with Express.js is something that every web developer should know how to do. Now that you have a decent understanding of the basics, we'll start looking at more advanced real-world projects.